In this lesson, sizokhuluma ngana topic analytical geometry. So it's gonna be the basics of it. Whether whether you grade 10, 11, or 12, it's gonna serve you. Yeah? It's meant for you. It's meant for every grade because analytical geometry sithola on every grade, right? Sithola on every grade. So yeah, thanks for tuning in, guys. Check out the description box. There's also gonna be links for other topics esobe siwa discussa for analytical geometry. Okay, so yeah. Now, what is analytical geometry? I'm sure Uti, you have done Euclidean geometry at some point at some point in your life, right? So we know that Euclidean geometry it mostly talks about what? Shapes, your triangles, your quadrilaterals, and the other shapes. Right? You also have done algebra as well, right? So analytical geometry, it's that bridging gap, if I may use that phrase, where sithatha algebra as well as Euclidean geometry and discussing it simultaneously. Because uma uthatha ukubheka algebra, what it does, it deals with ama calculations kakhulu, while as Euclidean it's more of a logical, it's relying heavy on logic nama proofs and reasoning kakhulu, right? So there aren't any ama calculations amaningi ku Euclidean, right? So lana we are trying to unify the two topics, algebra nani the Euclidean geometry. So it's basically a branch of mathematics where we use algebra as well as the coordinate system to study and solve geometric problems, right? So we are actually discussing Euclidean geometry using algebra. Okay, so there are key concepts. There are key concepts or ideas that are important when it comes to analytical geometry. Key, very key, very key, very key. These concepts isn't as fun nabu gradient, you know, how to calculate the gradient or the slope of a given line, right? Remember, on a triangle, you have a triangle like this. You have a quadrilateral, a fanana this one, right? So guess what? Lama shapes in what drawing allow. They are made up of what? Lines. They are being constructed by lines. This to here, it's a line. 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 A quadrilateral, it's made up of what? 4 lines. Triangle is made up of how many lines? 3 lines. So knowing how to calculate the gradient, knowing how to calculate the guys, distance or the length between 2 points. Actually, line iqala somewhere, iphelela somewhere, as well as finding the midpoint of a line. A line, lana geometry, it starts somewhere and it ends up somewhere as well, right? So knowing how to calculate the gradient, distance, and midpoint is not kakhulu in analytical geometry, okay, or understanding geometric shapes. Okay, so these are the key concepts lagu analytical geometry. So I'm going to teach you how to calculate a gradient. I'm also going to teach you how to calculate the distance as well as the midpoint. Okay, now let me just erase this. Let me take this away. You know what? Let's just take or choose a point. Maybe we can take. Should I have to? Okay, do I have to take 2? Nah. Let's just take this. Perhaps connect it with another point. Maybe right here. See big kunala. Alright, so let's call this point A, and let's call this point B. So it's 1, 2. So the coordinate is gonna be a 2. 1, 2, 3. So it's gonna be a 2 and a 3. A minus 5, and then Y. It's also a minus 5. Okay, so let us calculate iloganje. Let us calculate the gradient. Let us start with the gradient. Number one, gradient. Let me show you how to calculate the gradient, or to use the gradient formula. So the gradient is calculated by this formula. M is equal to y2 minus y1 over x2 minus x1. Okay, so in this case, sizoba na the following. See, we want to calculate the gradient between these 2 points, A and B. So sizoti, the gradient between A and B is equal to y A minus y B over x A minus x B. So this is how we're going to use the formula here too. Now let us calculate y A ile, right? Minus 5, so it's going to be a minus 5 minus the y of b, the y of b 3, so it's going to be 3 lana xa, it's a minus 5 minus xb, that's 2, equal to minus 5 minus 3, that's minus 8, over minus 5 minus 2, that gives us a minus 7. So dividing this gives us a what? A 8 over 7. We have got the gradient dimension a positive, right? A positive. Okay, so this is how we calculate the gradient between 2 points. But let me make some comments around gradient, right? So you can see that line to between these 2 points, the gradient or the line, the line between A no Logange. What am I saying? The line AB, gradient yakhona is calculated to be positive 8 over 7. So this is what I want to say. Ngale gradient. When a gradient, when a line ihleli kanje, ne? Ihleli kanje, it means that the gradient yakhona izohlezi positive. So m is always gonna be greater than 0. But then if your line ihlezi kanje, your gradient will always be negative. Izohlezi ubani negative. But then if your line is horizontal like this, the gradient of this line, it's gonna be m equal to 0, right? It's gonna be 0. But then if your line is vertically, so city gradient yalana, it's undefined. It's undefined. There is no gradient. There is no slope. So for a horizontal line, the slope is 0. When it's vertical, it's undefined. If your line is falling like this, ne, gradient yakhona iyoba negative. If it's rising like this, gradient yakhona izoba njani? Izoba positive. You know what? Just challenge yourself. Utate maybe points such as this. Such as this. Some utati point, utati another point, and then you connect the 2 lines. Now connect all my lines with 2, and then use those coordinates to calculate the gradient and see you actually get a negative gradient. Then we are where you tata a straight line, maybe this point and that point. You take a straight line, a horizontal. Take these 2 points, use them to calculate the gradient. You should obtain 0, and then you do the same thing for a vertical line. Okay, so that's a challenge for it. Now I want to interest you into another concept. Concept number 2, the second concept is the distance. Calculating the distance or the length. Whether ulaga grade 10, grade 11 or 12, you always gonna find a analytical geometry problem, ne? And the distance, the gradient, even in midpoint, you always gonna use these calculations, or find these calculations in one of your questions. Okay, so manje ke as calculate a distance between A and B. So distance AB, so we know that the distance formula ATD, okay, the D stands for distance, not dinosaurs, not donuts. Yeah. X2 and then x1 squared plus y2 minus y1 squared. Okay. Therefore, ngoba lana I'm calculating the distance between A and B. Or kanjani? Asibangeni. So, in order to calculate the distance between 2 points, again, we represent, so remove a lot D and place A, B la. I'm just saying what I'm calculating a distance between 2 points. I know I've seen calculations where they just use the formula as it is, but substitute ama points correctly. So maybe but you know what, I'm just gonna make B number 2 and then I'm gonna make A number 1, right? So where there's x2 you substitute u2, where there's x1 you substitute ubani minus 5. Okay, so mina I find it easy if I do it like this, right? I'm gonna do it like this: xa minus xb square this, right? So ngicala, okay, in each and every bracket ngicala ngo a ngilandele ngo b, ngicala ngo a ngisubtract ngo b, kanjalo kanjalo, right? Same thing I did with the Lagrange gradient. Then we add, then we're gonna have aya it minus yb square this, then you substitute again. It all right? Coordinate a minus 5 minus 5, then you coordinate b 2 and 3 sharp square root, so the open bracket xa minus 5 ngifaka minus 5 la ngithi minus xb ngithi 2 squared plus ya minus 5 ngena minus yb 3 hlala, then kuba ab la, and then say ab, this is equal to yeah, lang thing calculator la eliyashaya le calculation yo ngiphandlekile la. All right, I'm just gonna punch everything on the calculator. Minus 5 minus 2 plus minus 5 minus 3 square, I'm getting a square root of 113. So the answer le it, the distance from la all the way up to la, it measures square root 113. So this is how we calculate the distance or the length kulokanje lagu analytical geometry. All right, so next formula. All right, so for the next discussion, siyokhuluma ngani? Number 3, we're going to talk about the midpoint. The midpoint. All right, what is the midpoint really? In midpoint, it's that point esithola on the line iba between the end points. So if this is a straight line like this, and then ngithi kuwe, this is A, this is B, and then ngithi kuwe, all right, this is the line AB. It measures from la ukuya la, it measures 10 centimeter. So the midpoint, it's gonna be here. Izoba la midpoint, right? And the midpoint, it means that between UAB, let's call this M, the midpoint, let's just call it M, and then it means that if a midpoint ila, the distance between AM, it's gonna be 5, and between M no B, it's also gonna be 5. 5 plus 5 is equal to 10. So a midpoint, it's that point esithola midway in the line given. So nalana, I can estimate it, man, you know what, i midpoint yami ingaba somewhere lana. I don't know. But it's that point they divide your line into two. Yeah, bisect in a way, right? Yeah, bisect in a way. So how do we calculate the midpoints? It's the m x y equal to m x2 x1 over 2 y2 plus y1 over 2. Okay, over 2. So therefore, since I'm calculating a midpoint, I set the midpoint here to 9. Let me use the black on the sketch, sorry. So izobala midpoint yethu u-m le am uzoba equal to that, right? Izoba that. So sizowenza so in order to get the coordinates for m, for the midpoint, come on pen, come on, embarrass mara kunandaba mpinjam. Xy is equal to m, open bracket, so x yofaku a la it the x2, I mean b over 2. But began guys, it doesn't affect your calculations or ama-marks wako if you don't put a no b la, ne? But I just like to organize my calculations one. So my midpoint is gonna be xa minus 5 asum 5 plus xb 2 over 2 ya minus 5 plus yb 3 over 2 equal to m. Then your calculator minus 5 plus 2, that's negative 3 over 2. Then minus 5 plus 3, that's gonna be a minus 2. Let's say divided by 2. So the final answer is gonna be a minus 3 over 2. Minus 1. Yes, I was close. I was so close. Very close, very close. Okay, so this is the midpoint. This is the midpoint. So the fundamentals or the basic or the key ideas of analytical geometry have been discussed in the video here today. I hope you enjoy it. I hope you got some value out of this. Check out the description box for more recordings for the analytical geometry. Okay, so I hope you enjoyed. Catch you on the next one. Bye bye.